So in our quest to understand the world around us, we often invent forces to try to explain what's happening to us. Inertia is often misinterpreted as a force, and it's very common for objects that are moving around in a circular fashion, especially if you are the person that's moving in some sort of circular fashion, to sort of feel like you're being thrown outward. So objects that are a part of rotating systems often feel some sort of like outward kind of force, and it's really not there. We would call that force a centrifugal force, meaning center fleeing. That force really does not exist. What's happening is that all objects have inertia. They have a tendency to keep traveling in a straight line. If we consider something like pizza dough being spun around in a circle to try to make it into a wider pizza crust, we spin it. That spinning action tends to make the pizza dough sort of flatten out and become quite a bit wider. And the reason for that is simply that the objects that are part of that pizza dough have a tendency to travel in a straight line. As we spin it, that straight line sort of gets further and further away from the axis of rotation simply because of the fact that it wants to keep traveling that way. And so it sort of flattens out as it goes. Now, if you do the same thing with a salad spinner, you rinse your lettuce and salad and you put that into your salad spinner, you spin that thing around super fast. And as you spin that around, the lettuce, the water, everything else inside there has a tendency to travel in a straight line. Well, the walls sort of prevent that from traveling in a straight line, so they tend to accumulate on the outer edge. They're not thrown outward, they just tend to travel in a line that's straight, and so they will accumulate on the outer edge. Now, the water will, of course, seep through those holes and will accumulate down here. So it's a very effective way of drying our salads. Centrifuges work very similarly. In a chemistry setting, oftentimes we allow gravity or want gravity to sort of settle things out so that any kind of solids will sort of accumulate in the bottom and the liquids will sort of accumulate on top. Well, if gravity is too slow for that to happen, we will spin these things around super fast and allow the centrifuge itself to separate out those particles. Again, they are not being thrown outward, they travel in a straight line and since would accumulate on the outer edges. Now, probably the reason most people think there's a centrifugal force is because if you're riding on a merry-go-round and you're the one that's feeling like you're being thrown outward, I think I see why people think there's an outward force. If I'm riding on this thing, I'm going to end up having to hold on to these bars and sort of pull outward on those bars. Now, if I pull out on the bars, that's the force of me on the bars. The bars are going to pull me inward, right? So this is a Newton's third law idea. So I actually have an inward force acting on me. Of course, what I feel is the fact that I'm trying to pull outward on those bars. So this is where I think people think there's a centrifugal force, something that's throwing me outward. Now, when I consider a person in a car, okay, and let's say that this is me and this is another person in the car, and let's say that there's very little friction on those seats, and I'm going to go make this turn. Now, as I go to make the turn, there is a force required inward in order for me to make that turn. Well, as I turn the steering wheel and the car sort of moves into that turn, I see that the wheels will sort of push outward on the ground, and the ground sort of pushes inward on those wheels. That allows the car to turn, right? So that's pushing out that way. The car would be pushed inward. Now, to my left is the door. The door sort of pushes me inward and allows me to make that turn. Now, this person, without any frictional force, that person would tend to travel in a straight line. Now, it appears from these two people's perspective that they're sort of thrown outward toward the other person. In reality, they traveled in a straight line, and I was the one that sort of moved into them. Okay? And so it's very common for people to invent some sort of outward force. In reality, that's nothing other than inertia